All right, so everyone, good afternoon. Once again, as I said yesterday, we're going to continue with this lesson, the second part of solving trig equations. So in this lesson, we focus on solving trig equations with identities and factoring. Okay, so we're just going to finish off the problems that were in that lesson, starting with this question, question 4. So here we have cosine x plus 1 equals sine x, and here we're going to solve over 0 to 2 pi. Okay, so not all solutions. So in other words, we don't have to add like 2k pi, etc. All right, first thing we're going to do is square both sides of the equation, and notice here there is an asterisk. So at the bottom, I leave a note there. So I'll mention that later. But for now, let me just go through the algebra. So on the left-hand side, we get cosine squared x plus 2 cosine x plus 1, right? That's cosine x plus 1 times itself. And then on the right, we get sine squared x. At this point, we just use the Pythagorean identity, right? So we know that sine squared plus cosine squared is 1. And then we know that sine squared can be rewritten as 1 minus cosine squared x. Left-hand side stays the same. Okay, from there, you're going to add cosine squared x to both sides. You get 2 cosine squared x plus 2 cosine x, and then 1, you can subtract from both sides, so you get 0. So in the end, you get 2 cosine squared x plus 2 cosine x is 0. Okay. At that point, you're going to factor the greatest common factor, which is in this case 2 cosine x, and that'll be 2 cosine x times parentheses cosine x plus 1 equals 0. And then at this point, you have two terms that multiply to 0, so you can use the zero product property, right? You can set either of them equal to 0. So 2 cosine x equals 0. From that, we'll get cosine x is 0. And then at this point, you should realize that the angle should be 90 degrees or 270 degrees. Okay, that's when cosine is 0. Or in radians, that's pi over 2, 3 pi over 2. From the second equation, we get cosine x is negative 1. And for that angle, it's going to be x equals pi, which is 180 degrees as shown here in the diagram. Okay. But note here that 3 pi over 2 is not a solution. So for that, let me get to the note. So yeah, again, there's an asterisk there because squaring both sides of an equation may introduce new roots, which is why we have to check our solutions, right? So as another example, I give the example of like x equals 1. If you square both sides, you get x squared equals 1. And then if you take the square root of that and solving for x, then you get x equals plus or minus 1. But we know from the original equation that negative 1 is extraneous, right? Like if you plug a negative 1 into the original, right, negative 1 equals 1, that's not true, right? So you get extraneous solutions sometimes, right, if you square both sides of an equation. Okay, so to that end, we'll check each of the solutions. And from here, we can see that 3 pi over 2 is not a solution. Okay, so like if you plug 3 pi over 2 into the original, you get cosine 3 pi over 2 plus 1 equals sine 3 pi over 2. And then you get 0 plus 1 equals negative 1, which is not true, right? So 3 pi over 2 is extraneous. If you remember that word from algebra 2, it's just like a solution that comes up, but is actually not a solution once you check with the original equation. Right? Okay. But yeah, that being said, the final answer is going to be pi over 2 and pi. Okay. So pi over 2 and pi will be your final answer. Okay. If you have any questions, please ask them now. Well, also let me ask, is anyone still copying the solution here? No? Otherwise, I'll move on. Okay, all right. Just let me know when you're done. So, and anyone else who's copying this. All right. Anyone else still need it? All right. If not, then I'll move on to the classwork. Okay. So the classwork worksheet, just 3 problems. This is the same worksheet as the one from the last post on Google Classroom, which I show here on the screen, right? So actually, let me give you a chance to try solving this on your own. So try solving the first question, and then we'll reconvene in let's say 5 minutes. Okay, so at 1:37, we'll reconvene. All right, so at this point, well, let me just ask, did anyone come up with a solution? And feel free to type your answer in the chat or speak up. All right. All right, if not, then let's go to the solution then. So question 1, we had sorry, right here. All right, here we go. Okay, so here we had 1 plus sine x equals 2 cosine squared x. Here we're solving over all real numbers, so we are going to have to like add 2k pi, right? So first thing I do is I'm going to substitute cosine squared x. I'm going to replace that with 1 minus sine squared x. Okay, so you get 1 plus sine x equals 2 times 1 minus sine squared x on both sides. Sorry, on the right hand side. And then 1 plus sine x, you distribute the 2, so you get 2 minus 2 sine squared x. And then I want to combine this so I can, have a quadratic equation of sorts. And I say sorts because, here the square term is sine squared, sine x, right? So it wouldn't be like a parabola per se, like it wouldn't be like x squared, etc., but like has the same form, right? So yeah, we're trying to get to that form so we can factor. We get 2 sine squared x plus sine x, and then 1 minus 2 is -1, and then equals 0. From there, you can factor, okay? But the leading terms in both terms has to be like 2 sine x and sine x, right, to get the 2 sine squared x. And then from there, the other terms are going to be 1 and 1, right, because 1 times 1 is 1. And after some guess and check, you can see that it's going to be negative here and then positive here. And to double check, you could do like 2 sine x times sine x, that's 2 sine squared x. Then 2 sine x times plus 1 is 2 sine x, and then -1 times sine x is negative sine x. Right, so that'll sum to the 1 sine x here, and then -1 times positive 1 is -1. That equals 0. From the first term, you get sine x is 1/2, so your two angles are going to be pi over 6 and 5 pi over 6, or 30 degrees and 150 degrees. From the second equation, you get sine x is -1, and as you see from the diagram, that's 3 pi over 2 here, right, 270 degrees, right? That'll be the only solution between 0 and 360. Okay, and then at this point, all you have to do is add 2k pi to each of these solutions, and where k is an element of Z. All right, give you a sec to copy that down. Yeah, question?
Did we have to like check for like any extraneous solutions in this problem?
Oh, no. Yeah, so extraneous solutions will come up like if you square both sides. The mathematical term for that is like an irreversible operation, meaning like if you square it, then like you kind of like don't know what the originals are. So like if you square x equals 1, right, then you get x squared equals 1. But like you don't know if it was like x minus x equals -1 originally or x equals 1. So something like that. Yeah. So yeah, here we didn't, do anything like that, so you don't have to check. But you can always check if you want. You can like plug in these answers and see if it works. Yeah. That's fine. All right. Does anyone need these or need to copy this? Okay. And I'll post this, the lesson plan as always, in case you need it. All right. So let me move on to question 2. Here we had 3 cosine squared x minus 13 cosine x plus 4 equals 0, and we're solving from 0 to 360 degrees. Okay. Here we're going to use the AC method of factoring, right? So 3 times 4 is 12, and you have to think of two numbers that multiply to 12 that will add to negative 13, right? That should be negative 12 and negative 1, right? So that tells us how to split up the middle term so that we can factor by grouping. So we get 3 cosine squared x minus 12 cosine x. And just to emphasize my point, I'll write negative 1 cosine x here. All right, we have the negative 12 and negative 1 here. And then plus 4 equals 0. From there, you can factor out 3 cosine x. From these two terms, you get 3 cosine x times cosine x minus 4. And then negative 1 times cosine x minus 4 equals 0. From there, you factor out the common factor, which is cosine x minus 4. From both these terms, you get 3 cosine x minus 1 times cosine x minus 4 equals 0. Okay. Then at this point, you can use the zero product property. For the first equation, you get cosine x is 1/3. Okay, and that'll be x equals arc cosine of 1/3. So note at this point you have to use your calculator. Okay, so like 1/3 is not a common value for cosine, so we will use our calculator for that. But before I get to that, let me get to the second equation. So from the second equation, we get cosine x is 4, and there's no solution, right? Because the max value of cosine is 1. Okay, so no solution for that. And then back to the first equation. Using your calculator, I'm going to write it in terms of radians and round it to 5 decimal places. You get arc cosine of 1/3 is 1.23096 radians. Okay, so that's one answer. The other answer, since cosine is also positive in quadrant 4, as you can see from this diagram, right, quadrants 1 and 4 are where cosine is positive. We get 2 pi minus x for the other answer. Right, so that'll be like over here. So the angle we're trying to find is in blue, right? Well, technically, yeah. So it's 2 pi, like 360 degrees minus this angle here, right? That'll be 5.05223 radians, and that'll be both your answers for question 2. Okay, all right, take a sec to copy this down, and then I'll move on to the last question, question 3. All right, anyone still need a copy too? Okay, just let me know when you're done. Okay. All right, anyone else still need it? All right. Well, actually, I can leave it there. But like, yeah, question 3 is actually pretty short. So question 3, we had sine squared x equals 4 minus 2 cosine squared x on R. And on the left-hand side, I changed that using the Pythagorean identity, right? So that can change to 1 minus cosine squared x equals 4 minus 2 cosine squared x. And then combining the cosine squared x terms, you get, I add 2 cosine squared x to both sides. You get cosine squared x on the left. And then subtracting 1 from both sides, you get 3 on the right. Okay. So cosine squared x equals 3, and then take the square root of both sides, you get cosine x equals plus or minus root 3. And actually, there's no solution here. So yeah, that's actually it for the question. because the max value for cosine is 1, right? And square root of 3 is larger than 1. And then same thing for negative root 3, right? The min value will be negative 1. And so you can't like get negative root 3 from cosine without it being transformed, okay? So in other words, there's no solution. And yeah, you can always, check using your calculator, right? You can do arc cosine of square root of 3, and you'll see that there's no solution. All right, so take a text to copy that down, and then with the time we have left, I can go over one of the homework questions for this lesson. All right, anyone still need this? Question 3. All right. If not, move on to the homework questions. So let me go over one of them. I'm gonna go over the last one because that was difficult. All right, so question 48. This is the homework assignment due on Monday night. Okay, so just giving you a heads up, and part of the reason why I extended the deadline instead of making it due tonight is because the problems were difficult. Okay, so let me go over 48, the last question. Here we had 3 secant squared x plus 4 cosine squared x equals 7. And as you can see, right, we're going to come up with, a way to factor this, right? So first thing I do is rewrite secant squared x as 1 over cosine. And then you square that, so you get 1 over cosine squared x. And then here I'm going to multiply everything by cosine squared x. Okay, so you have to be careful here. So here you have to assume that cosine squared x is not equal to 0, right? Because, if you multiply a false equation by 0, right? Let's say you have like 1 equals 2, and you multiply both sides by 0, you get 0 equals 0. But you know that the original is not true, right? So here we have to assume that cosine squared x is not equal to 0. So this will be another case in which you have to check for extraneous solutions, okay? But yeah, so after you multiply both sides by cosine squared x, right? I do that to get rid of this fraction here. You get this, and then I'm going to combine everything to one side. So you get 4 cosine to the 4th x minus 7 cosine squared x plus 3 is 0. From there, I'm going to actually use this method called U substitution, which you are going to see again in this class as well as calculus. Okay, so what I do here is, so since this is a quartic term, so like it's to the 4th power, I want to make this into a quadratic so I can factor it more easily. Now, technically you could factor it as is, but I find it easier to substitute. So I'm going to let u equal cosine squared x. And if u equals cosine squared x, then cosine to the 4th x is u squared, right? So this will become a quadratic. So you get 4u squared minus 7u plus 3 equals 0. And at this point, you have to use the AC method of factoring. So 4 times 3 is 12. And then two numbers that multiply to 12 that add to negative 7 are negative 4, negative 3. So I'm going to rewrite negative 7u as negative 4u and negative 3u. And then you factor, you get 4u times u minus 1 minus 3 times u minus 1 equals 0. The common term there is u minus 1, so you get that. And then from here, u equals 3/4, right? So 4u minus 3 equals 0. So that will give you u equals 3/4, or u equals 1. Okay. And then at this point, I substitute back. So u equals cosine squared x, right? As you can see here. And then you can solve. So from this equation, cosine squared x equals 3/4. Take the square root of both sides, you get plus or minus root 3 over 2. There you get these 4 angles, right? 30, 150, 210, and 330. From this equation, cosine squared x equals 1. You get cosine x is plus or minus 1, so that would be 0, pi. 0 and pi, between 0 and 360, non-inclusive of 2 pi. Okay. But anyways, if you check these answers, I didn't show that work here because I ran out of space, but You're going to end up with these answers. So 0, 30 degrees, 150. So that's 0, 30, 150. Then 180. Then 210, which is 7 pi over 6. Then lastly, we have 330 degrees, which is 11 pi over 6. All right, so while you copy that down, if you need it, let me close with announcements. One, there's SGI today at 2:47 in case you have questions. Feel free to ask me about this homework. You can even just I can even just show you the solutions if you want during SGI. Secondly, reminder that our next quiz is next Friday. Okay, so I'll send out a topics list per usual over the weekend. And third, as a final reminder, if you did not submit a private comment on Google Classroom regarding partial credit about quiz 3, you need to do so by today. Okay, because I'm going to regrade for partial credit over the weekend. Again, most of you have done this already, but some of you haven't. So just let me know. Okay. All right, that's all I want to say for today. If you have no further questions, you are free to go, and I'll see you on Monday. All right, have a great weekend.
Have a nice
Have a
weekend.
good weekend.
Have a good weekend.
You too.